Hello everyone, Tom McNamara here for our course in trigonometry. In this video we are going to discuss working with inverse trig functions. Now we had touched on this a little bit before and we're going to use it again in some subsequent material about solving trig equations. So I thought I might review the basic ideas in this video. So you'll remember the basic principles of a function is you have a set of inputs and you have a set of outputs. The set of inputs is called the domain. The set of outputs is called the range. For a trig function, the input is an angle, sometimes measured in degrees, sometimes measured in radians, and the output is a ratio. And an inverse trig function will take a ratio and give you an angle. So inverse trig functions become kind of useful when we know the, let's say, the output value of a sine function, and we want to know the angle that produced it. For example, when we're solving a triangle. If we're solving a right triangle and we know the three side lengths, but don't know the acute angles, we can use inverse trig functions to get the angles. Okay, so just a couple of warm-up problems. Evaluate each. Cosine inverse of 1/2. All right, so I'm supposed to come up with an angle whose cosine is 1/2. Since I remember my special triangles, I know that side lengths of 1 and 2 come up in a 30, 60, 90 triangle. Hypotenuse is length 2, the short side is length 1, the radical 3 is next to the 30. All right, now, here's the thing, right? If I want the cosine to be 1/2, I'm talking about adjacent over hypotenuse, so it's looking like 60 degrees or pi over 3 radians. That would be the angle that does that job. Okay, now there are some cases where we need to break out our calculators and use that. So for example, if I wanted to find arcsine of 0.4328, so I would do 0.4328, helps if I turn the calculator on, 0.4328, and then do second, and then inverse sine. So we're talking about approximately 25.6 degrees. One important thing to note here. We have two notations. Okay, the notation that is typically used on your calculator for the inverse trig functions is an exponent of -1. An alternate notation is putting the word arc in front of the function's name. Okay, so over here, you might say, well, what the heck is arcsine? Arcsine means the same thing as sine inverse. It's an inverse trig function. This is fairly common nowadays because of the calculators. This avoids the possible confusion of thinking we'd be talking about the reciprocal of this thing when, of course, we're talking about a totally different function. Okay, so if I took the sine of 25.6 degrees, I should get 0.4328. You can check that on your calculator. All right. Now, here's one little peculiarity I need to point out about these inverse trig functions. Okay, so in this example, we're going to take sine inverse of sine of 120 degrees. Okay, now remember, we need to work inside the parentheses first, right? We got to follow the rules of algebra. So take sine of 120 and then take the inverse sine of 120 of this value. Okay, now you might be saying, well, this is a silly exercise. These two things are just going to cancel each other out. So let's try it on our calculator. Make sure you're in degree mode when you do this. 120 degrees, take the sine. Now take the inverse sine. Okay, and as you can see, my calculator is giving me 60. It's not giving me 120 back. Okay, now here's what's happening. Let's think about the graph of the sine function. We're going to have to kind of think in radians here, but that's same difference. Okay, let's think about the graph of the sine function. Okay, we spent quite a bit of time drawing these graphs. We know that the period for the sine function is 2 pi. And that we also know that this cycle, this exact picture, repeats over and over again forever. Okay, so when you're dealing with inverse trig functions, you're basically reversing the roles of the input value and the output value. Okay, so when I'm looking at this graph of the sine function, the fact that pi over 2 comma 1 is on the graph means that if I put pi over 2 into the sine function, 1 comes out. Okay, x coordinate's the input, y coordinate is the output. An inverse function swaps those roles. You start with the range of the original function, and the inverse function takes you back to the domain. Remember that picture we had up on the board a while ago. Okay, so the sine inverse function is basically focusing on this part of the graph. It's going to start with a y value wherever you want, and it'll give you a angle that's between minus pi over 2 and pi over 2. Okay, in other words, between minus 90 and 90 if we're in the degree system. So this isn't just spitting back out 120 because 120 isn't in the range of the sine inverse function. So let's talk about the ranges of these functions. Sine inverse has a range of minus pi over 2, let me write it this way. For any x value, sine inverse is going to give you something between minus pi over 2 and pi over 2. Same thing for tan inverse. Actually, I guess for tan inverse is actually not equal to, but don't worry too much about that. Now, cosine inverse is going to throw us for a little bit of a loop. cosine inverse is going to give you something between 0 and pi, or if you're in degrees, between 0 and 180. Okay, so that's the basics. That's where these functions live. That's what the inputs and outputs are going to be telling you. Okay, so let's talk about something like this here. Okay, let's evaluate each one of these. I'll pull some examples out of our book. Alrighty, so let's try this one first. I'm going to do cosine of cosine inverse of 3/5. Okay, now you could actually pull out your calculator and try this, but I actually don't think we need to, because notice there's a slight difference in the setup of what I had last time. Notice what I was setting up last time. I had sine inverse of sine of 120. That's what we had on the board a second ago, and that was where we had this unusual thing. Okay? The sine inverse was on the outside, and the sine inverse has a limited span of output values. It's always going to give us something between minus 90 and 90, so it's not going to give us 120. However, that's not the case here. Okay, so this is just going to be 3/5. Okay, so if you have an ordinary trig function on the outside, you're good to go. Now, if you have an inverse trig function on the outside, you need to be careful. Okay, so what you're doing here is you're using an angle that has 3/5 as its cosine, as the input to the cosine function. So you're getting 3/5. If you have an inverse trig function on the outside, that's where you got to be careful. Okay, so let me do an example like something like this. Okay, sine inverse of sine of 330 degrees. Okay, now here's where I got to think a little bit. Because if I just say this, okay, that's incorrect. No. Sine inverse will never give me 330 as an output. Okay, so what I'm thinking about is I'm thinking about my unit circle. Okay, 330 puts me right here in the fourth quadrant. And what I'm thinking about is, can I come up with an angle between minus 90 and 90 that is coterminal with 330 degrees? And that's easy enough. Minus 30 degrees would be coterminal with 330. Remember, negative angles, we rotate the opposite way. When we're talking about angles in standard position, we get the positive x-axis go in the counterclockwise direction. Negative angle, we're going in the clockwise direction. Okay, so this negative 30 is coterminal with 330, and that is between minus 90 and 90, which is where the sine inverse, which is where the sine inverse is living. Okay, so if I take sine of 330 and then do the sine inverse of that, I'm going to get minus 30. Okay, I want to change it up a little bit even more here. Let's throw a couple of things together. Let's do tangent of sine inverse of 3/5. Tangent of sine inverse of 3/5. Okay, now this one's a little different. Here we're just kind of using, well, right here, this was the easiest kind. Regular trig function on the outside, inverse trig function on the inside. That's the easiest kind, you don't have to do anything. Here you got an inverse trig function on the outside and the related trig function on the inside. So we did some reasoning here and thought about, okay, we know sine inverse is going to give us something between minus 90 and 90. That's just where that function lives. So what is something coterminal with this angle that's in the range of minus 90 to 90? We came up with minus 30. Here we got a different trig function on the outside. So it's certainly not going to like cancel out or anything, okay? Sine would cancel out sine inverse, but tangent doesn't do that. Okay, so let me erase this a sec. And let's think about what sine inverse of 3/5 is. Sine inverse of 3/5 is an angle with 3/5 as, let's call it, it's an angle theta with 3/5 as sine theta. So let's go back to our right triangle definition of these trig functions. So I got an angle theta where the sine is 3/5. Now sine is opposite over hypotenuse. Okay, so I got a right triangle here, opposite side 3, hypotenuse 5. Doesn't take long to figure out that the adjacent side has to be 4. Okay, and now that I've got all 3 sides in my triangle, well, tangent is opposite over adjacent, so tangent is 3/4. Okay, so you can apply different trig functions to these angles. The key is you just go back to that right triangle definition of your trig functions, and you apply that. Okay, if you know the sine, then you know the opposite and the hypotenuse. You can use the Pythagorean theorem to figure out the remaining side. And then once you've got all 3 sides, you can figure out any of the trig functions. Okay? So if I wanted to do cosine of sine inverse, of 3/5, I could do that too. That would be 4/5. Okay? Cosine of sine inverse of 3/5 is 4/5 because cosine is adjacent over hypotenuse. Okay, so the things to be careful about when you're dealing with these inverse trig functions is remember they have a restricted range. Sine inverse and tangent inverse will always give you an output value between minus 2 pi, or minus pi over 2 and pi over 2, between minus 90 and 90. Cosine inverse is different. It'll give you an output value between 0 and pi, or, if you like, between 0 and 180.